We have two different standpoints by which we can interpret our universal propositions, our propositions A and E. So we've already looked at the Boolean standpoint or the modern standpoint, and on those standpoints we don't commit ourselves to the existence of things when we assert an A or an E proposition. So if I say all dogs are mammals, I don't actually commit myself to dogs existing from the Boolean standpoint. The Aristotelian standpoint differs. On the Aristotelian standpoint, if the things that I'm talking about do in fact exist, like dogs, then I do become committed to their existence when I assert an A or E proposition about them. So if I say no dogs are fish, I am committing myself to dogs existing. Whereas if we talk about things that don't exist, such as unicorns or leprechauns, gnomes, etc., if I say no gnomes are mammals, for instance, then I have not committed myself to the existence of gnomes. So being that that's the case, when we diagram on the Aristotelian standpoint or the traditional standpoint, we need a different way of diagramming those. And as we'll see, we also need to understand the different types of relationships that happen on a square of opposition. So those are going to be different from the Aristotelian standpoint than from the Boolean standpoint. So let's take a quick look and get a feel for what this modified Venn diagram technique is going to be like. Looking at this A proposition, all S are P, we'll recall that from the Boolean standpoint, we're going to have to shade out area 2. And we're still going to do that from the Aristotelian standpoint, because what we're claiming is that everything that is an S is going to have to be a P. But area 2 is a place where you could have S's that are outside of the P circle. And that violates what we're saying, so we have to get rid of it. And that is, we have to shade it. But then the difference, as we were just discussing, is that from the Aristotelian standpoint, we can be committed to the existence of things from these A propositions, so long as the things in question do in fact exist. To represent that, we put those things that we might be committed to, we represent that with a circled X. So the circled X indicates that on the condition of there being an S that exists, then that S is also a P. So all S are P. If we're talking about dogs, for instance, then we are in fact committed to dogs existing. We put an X here with a circle around it. But we actually also, even if we're talking about unicorns, we put this circled X. The circle just reminds us to look to see whether unicorns in fact exist. Well, they don't, so then we are not committed to their existence. We get the same type of thing here with the E proposition. We start off diagramming it like we would from the Boolean standpoint. So if we say no S are P, well, the only area where we could have S's that are P's is area 3, but we're told that we can't have those. So we got to shade it out and get rid of it. And then we have to represent to ourselves that if there are S's that exist, then we'll be committed to them. And that's going to be in area 2 because it always corresponds to whatever the subject term is that we're talking about. And then we put that thing in the only area that's left for S's. In this case, that's area 2. So again, the circled X indicates that on the condition that we're talking about, say, dogs as opposed to unicorns, then we do in fact have an S. We are committed to its existence, and it's not a P. So for both of these cases, that's what we mean when we say existential import. Our A propositions and our E propositions have existential import. They commit us to the existence of the subject matter that they're talking about, so long as those terms, those subject terms, in fact refer to things, so the things in question do in fact exist. So here we have a couple of arguments that move from the universal proposition to a particular proposition. So let's diagram these and take a look at them very quickly. We've already seen just in the previous slide that diagramming this A proposition from the Aristotelian standpoint, we shade the area that I'm shading right now, and then we need to put a circled X corresponding to the remaining S, the remaining area of S. From the Aristotelian standpoint, we diagram our particular statements just as we would diagram them from the Boolean standpoint. And that's because the Aristotelian standpoint and the Boolean standpoint only disagree on whether our universal propositions have existential import, whether they commit us to the existence of the things that we're talking about. So then, as we said in the previous slide, the way that we're going to diagram E propositions, so we get rid of the middle part because that's where we can have both S's and P's, but we're saying we can't have those. And then we put a circled X, again, for the remaining S circle, whatever takes the subject placement. And then again, some S are not P, we diagram just like we would from the Boolean standpoint. So we put an X here. Notice then that if premise 1 is true on this left argument, and if what we're talking about in fact exists, so we're talking about dogs as opposed to unicorns, then because we get committed to the existence, because we get committed to there's something really being here, it will follow, it will be true that some S are P. So under the Aristotelian standpoint, if we're talking about things like dogs or books or trees or whatnot, we have a valid argument here. We see the same type of phenomenon in the argument on the right. If we have premise 1 and we're talking about dogs, books, trees, etc., then we really will get committed to something existing in this area, in the S remaining area of S. And so there will really be an S that is not a P. Again, if this premise is true, then this conclusion would have to be true. And again, we have a valid argument. On the other hand, if what we're talking about doesn't exist, if we're talking about unicorns, or we're talking about leprechauns, etc., then what the circle tells us to do is to ask ourselves the question, in this case, do unicorns, do leprechauns, does the subject matter in fact exist? And if the answer to that is no, then we don't get the X here. And then we commit a fallacy, what we call the existential fallacy. Because the validity depends on the condition of whether something exists or doesn't exist, we initially call the relationship between these premises and these conclusions as being conditionally valid. Valid on the condition of whether there in fact exists, whether the subject matter exists. Then we go on after determining whether it's conditionally valid to determine whether it is valid wholesale. And to do that, we have to check to see whether things really do in fact exist, whether the subject matter in fact exists. If the answer is yes to that, then we move from conditional validity to saying that it is valid. However, if the subject matter in the subject class does not exist, if it's empty, then we move from saying that the argument is conditionally valid to maintaining that it is invalid and actually commits the existential fallacy. What I want to do in these next couple of slides is just give you a procedure, a decision procedure for Venn diagramming from the Aristotelian standpoint. And the point of these steps is if you follow them and you follow them correctly, it will output the correct answer for you. So it might be useful to have these in your notes so that when you're doing your homework, you can refer to them to make sure that you're doing this correctly. The first thing that I suggest is that you label the classes in play to locate them and determine the areas that are in play. So for instance, if we have a statement that says all non-A are B, it can be pretty confusing to just try to figure that out in your head without any visual aids to help you figure out what needs to be shaded and what doesn't need to be shaded. So if we have our A circle on the left and we have our B circle on the right, since we're talking about all non-A's, I also want to label where my non-A's are. So one place that we find non-A's are outside of both the A circle and the B circle, but we also have non-A's on the right side of the B circle, because that's outside of the A circle. And since our statement says that all non-A's are B's, when I look at this non-A, which is everything that's outside of the A and B circle, I see that they're not B's, but we're being told that all non-A's are B's, which means we need to get rid of this area. So by labeling where my non-A's are, where all of my non-A's are, and also knowing where my B's are, that allows me to visualize and to cut down the number of variables that I have to hold in my head to be able to see what it is that I need to do to represent that in my Venn diagram. All right, so after we label what's in play, in this case it was our non-A's and our B's, then the next thing that we want to determine is whether we're going to shade and circle X, which is what we do with universal statements, universal propositions, or whether we're only going to put in X without the circle, which is what we do with our particular statements. For the third step, determine where you would shade and circle X or merely X the diagram to make the standard form portion of the proposition true. So I'm not yet telling you to shade and circle X or merely X the diagram. What I'm saying is figure out where you would for the part of the proposition that's in standard form. So what do I mean by that? Well, sometimes the propositions that we're going to deal with start with it is false that. So it is false that, and then we're given a proposition in standard form. For instance, all A are B. And what the third step is telling you to do is to ignore the part that says it is false that, and first think about how you would diagram the part that is in standard form. In this case, all A are B. So then in the fourth step, if your proposition didn't even have it is false that in front of it, then you just shade and circle X or put a mirror X how the third step told you to do it. That is, you just go ahead with what the third step tells you. But if it is not in standard form, that is, it's got the it is false that, then you do the opposite. So then where the third step, you merely X where you would have shaded and you leave out a circle X, or you shade where you would have merely X'd and put a circle X for the subject class area. So if you go through all those steps systematically, you should always output the correct answer. But hopefully with enough practice, you won't really need, you'll be able to stop referring to these steps. You'll be able to do it just from memory. So let's practice applying this decision procedure. We'll look at no S are non-P here on the left side of the screen. Ask yourself, how would you go about diagramming that, given that we have this is area 1, this is area 2, this is area 3, and this is area 4. So you can go ahead and pause the video and work that out, and then I'll talk about how we should diagram that following the steps. Okay, so the first thing that we should do, since it says no S are non-P, is to figure out what areas do we have our S's. I already have that labeled for us. So our S's are in area 2 and 3. The next thing we want to figure out is where our non-P's are. We have a non-P in area 1, and we have a non-P's in area 2 because those are outside of the P circle. And then when I think about what we're saying when we say that no S are non-P, we're saying that for any area in which there are S's and non-P's that allow for that, we have to get rid of them. Otherwise, that makes the statement false. Well, area 2 is where we have S's and non-P's. So I got to get rid of that area. Now, since this is from the Aristotelian standpoint, I am conditionally committed to S's existing, depending on whether they do in fact exist or not. So to represent that, I put the circle X in 3, because it's the only area in which there are S's. All right, so if we look at the argument on the right, and we have area 1, 2, 3, and 4. You can pause the video, work out how you think that should be diagrammed, and then I'll talk about it here in a moment. All right, so now we're worried about non-S's and P's. So I want to figure out where my non-S's are. Area 1 is where I find some of them. But area 4 is also outside of the S circle, so that includes the non-S's. We're also worried about the P's, and I already have those labeled. So again, I think about what no non-S or P says. It says there can't be an area that allows for non-S's and P's. Well, that's area 4. So I shade out area 4, and now none of our non-S's are P's. Here my subject term is non-S, so my circle X goes in the remaining area in which we have non-S's, which will be area 1. This last argument says that all non-P are S. And we have area 1, 2, 3, and 4. You can go ahead and pause the video, work that out, and then I'll discuss it. All right, first we want to locate where all of our non-P's are. We have non-P's in area 1, and we have non-P's in area 2. And we're told that everything that is a non-P is an S. Well, area 2 is where we have non-P's that are S's, but area 1 is where we have non-P's that are not S's, because they're non-S's. So we have to get rid of this area. And then we look at what our subject term is. It's non-P. The only area left where we have non-P's is area 2. So I put a circle X there indicating that if non-P's are the kinds of things that exist, then I am in fact committed to their existence. Now we turn our attention to the Aristotelian square of opposition. And one of the things that's really important to understand about the Aristotelian square is that we will only be using it when the universal propositions in question in fact have existential import. That is, when we're talking about dogs, when we're talking about books, when we're talking about rocks, when we're talking about things that in fact exist. Now, if we're talking about unicorns or leprechauns or gnomes or things that don't exist, we revert back to the Boolean standpoint. And the reason for that is the various kinds of relationships that instantiate on the Aristotelian square of opposition that don't instantiate on the Boolean square of opposition are a result of the commitment to those things that exist. So let me clarify that by looking at the square that I have here for us. I'm going to make this square bigger. And I'm going to get rid of that red line. Okay. So the first thing that I want to note is the similarities that this square has with the Boolean square. In our upper left-hand corner, we have our A propositions. In the upper right-hand corner, we have our E propositions. In our lower left-hand corner, we have I propositions. And in the lower right-hand corner, we have our O propositions. So those are the same, and those are still going to be contradictories of each other. So our A propositions and O propositions will always have the opposite truth values, and our E propositions and our I propositions will always have the opposite truth values. Now let's look at what's different about the Aristotelian square. Let's start with the top and look at A propositions versus E propositions. If we think about what we're committed to with A propositions that have existential import, we're committed to there being nothing in the left side of the A circle and to there being at least one thing in the overlap between the A and B circle. And for the E proposition, we're committed to there being nothing in the overlap of the A and B circle, but we are committed to at least one thing in the A circle. Notice then that these cannot both be true at the same time, because this says there's nothing in this overlap circle in the E proposition, but our A proposition says there's at least one thing there. Well, those can't both be true. And it can't both be true as that there's nothing in this left side of the A proposition, the A circle, and that there is something on the left side of the A circle according to the E proposition. So they cannot both be true, and if they cannot both be true, we call those contraries. So A and E are contraries. Notice also we get this relationship that we call subalteration. If we are committed to the existence of something in the overlapping area of A and B, then we can move from the proposition that all A are B to the proposition some A are B. If all of our A's are B's and at least one A exists, then there's got to be at least one A that is a B. So our truth, the truth of A, flows down to its corresponding I statement. But likewise, if we say that it's false that there exists something that is an A and a B, some A are B, then we would have no X here. This would be instead shaded out. And it would have to then be false that all A are B, because there can't be anything that exists here. So our false, if our I proposition is false, its falseness flows up to its corresponding A proposition. And we have the same type of relationship happening with E statements and O statements. If an E statement is true, then again it commits us to there being at least one thing that's in the A proposition that's outside, in the A circle that's outside of the B circle. Which means that there is at least one thing that's an A that's not a B, or some A are not B. So its truth, again, flows downward to the O proposition. So if an E proposition is true and we're committed to the existence of its subject matter, then O proposition will be true as well. And if the O proposition is false, which means that there can be nothing in this area, in the area that's on the left side of the A circle, then an E proposition that commits us to the existence of its subject matter cannot be true. It's going to be false as well, because there can be nothing here in this left side of the A circle. The last relationship is subcontraries. And whereas contraries cannot both be true at the same time, subcontraries cannot be false at the same time. The reason why is if, start with this I proposition, if it's false, then because it's contradictory with the E proposition, then we know the E proposition is true. But if the E proposition is true, then it commits us to the existence of there being at least one thing in the left side of the A circle. And so this must be true. So we go from the contradictory relationship to this being true. Truth flows downward, so our O proposition has to be true. So if the I proposition is false, the O proposition has to be true. And then we'll see the same thing happens with the O proposition. If the O proposition is true, if the O proposition is false, then because of the contradictory relationship, we know that the A proposition is true. Then by subalteration, we know that the I proposition has to be true. So when one is false, the other one has to be true. Now they can both be true. They just cannot both be false. I just want to reiterate yet once again that if we're talking about non-existent things such as leprechauns and unicorns and gnomes and whatnot, then instead of using the Aristotelian square of opposition, we revert back to the Boolean square, because it's being committed to the existence of things from the universal propositions that's forcing all of the additional relationships such as contrary, subcontrary, subalteration. If we are talking about non-existent things, then those relationships don't hold. So if we say all unicorns are one-horned animals because unicorns are non-existent things, we go back to the Boolean square, and it won't follow that because all unicorns are one-horned animals that there are some unicorns that are one-horned animals, because we will not be committed to the existence of unicorns. So from the fact that all unicorns are one-horned animals is true, it'll be undetermined whether some unicorns are one-horned animals. Let's get some practice using the Aristotelian standpoint. What we're going to do is look at some propositions. We're going to see how they are related, so based on the Aristotelian square of opposition. So are they contraries? Are they contradictories? Are they subalternates? Are they subcontraries? We are going to make the assumption that the subject terms of these propositions, in fact, denote existing things. And then using the Aristotelian square of opposition, we want to determine the truth value of our second statement on the basis of our first statement. So if we take a look at these two propositions, we have some A are non-B, some A are not non-B. First, determine how are these related given the Aristotelian square of opposition. If we look at our square of opposition, one thing that we'll note is that this is an I statement, this is an O statement, and so these statements are subcontraries of one another. And what the subcontrary relationship tells us is that they cannot be false. They cannot both be false at the same time. Which means that I can only know the truth value of O if the truth value of the I statement here was false, because that would force the O proposition to be true. But subcontraries can be both true. They can be both true, or one can be true and the other one can be false. So I'm not able to tell which one of those given the information that we have. So it's undetermined. So now let's look at these propositions. All non-B are non-A. Some non-B are non-A. Again, what we want to note is that this is an A proposition, and this is an I proposition. They're related as subalternates. And if you'll recall, the A proposition, our A propositions are on the top left of our square, the I propositions are on our bottom left, and truth flows downward. But we're not told that this proposition is true. We're told that it's false. And because we're told that it's false, we don't know whether the I proposition is true or false. So again, it is undetermined. Now let's use the Aristotelian square of opposition to determine whether the following arguments are valid or invalid. So we're going to again assume that the subject terms of these propositions do in fact denote objects that exist. So in our first argument, we have all non-A are non-B. Therefore, it is false that no non-A are non-B. To get you started, first, think about the relationship that these propositions have with one another, and then use that to determine whether you think, because the premise is true, the conclusion has to be true. That is, determine whether the argument is valid. I'll give you a moment to figure that out, to work that out. So the proposition in our premise is an A proposition, and the proposition that we're being told is false, and our conclusion is an E proposition. A propositions and E propositions are contraries, which means that they cannot both be true at the same time. We test validity by saying if the premise is true, then the conclusion must be true. If the premises are true, then the conclusion must be true. Well, on the assumption that our A proposition is true, since our A proposition and our E proposition are contraries, they cannot both be true at the same time. Our E proposition would in fact have to be false, which is just what our conclusion says. So it is valid. Now if we look at the next argument, it says it is false that some A are not non-B. Therefore, it is false that some B are not non-A. This is a bit of a trick question. Notice that our propositions are not uniform, because one talks about A's not being non-B's, whereas the other talks about B's as being not non-A's. But to use the square of opposition, these would have to be uniform. We'd have to be talking about A's in the same places, and we'd have to be talking about non-B's or non-A's in the same places. So the relationship that we have between these propositions cannot be captured by our square of opposition. Instead, what we note is that these are contrapositions of one another. They've switched out the predicate terms, and they've given them their complementary class terms. So then the question is, given that they're contrapositions, are they logically equivalent to one another? Well, contrapositions work on A propositions and O propositions. This is in fact an O proposition. So if it is true that this O proposition is false, then it's going to have to be true that its contraposition is false, because they're logically equivalent. The argument then is valid. Let's look at the last argument. It says that it is false that all B are non-A. Therefore, it is false that some B are non-A. This one will use the Aristotelian square of opposition. So use that to determine whether it's valid or invalid. And the first thing that we want to do is identify the kinds of propositions that we're being told are false. And the premise is an A proposition. And the conclusion is an I proposition. So these are subalternates of one another. Now our premise tells us that our A proposition is false. But only truth flows downwards to I propositions. Falseness doesn't. And since falseness does not flow downwards, we cannot know from the fact that it is false that all B are non-A, that it is false that some B are non-A. So this argument is invalid.